Em 2015, 150 líderes mundiais concordaram em implementar os 17 Objetivos de Desenvolvimento Sustentável em todo o mundo até 2030. O nosso grupo foca-se no Objetivo 7, Energia Acessível e Limpa. A energia acessível e limpa é toda a energia renovável, como a solar, eólica ou hidráulica, proveniente de fontes ilimitadas com efeitos negativos praticamente nulos para o ambiente. Um exemplo de um país que se está a afastar de combustíveis fósseis e a utilizar cada vez mais energias renováveis e acessíveis é a Austrália. Elon Musk interessou-se em criar este projeto na Austrália quando o estado da Austrália Meridional, devido a uma tempestade, ficou sem eletricidade. Musk prometeu completar a bateria de 100 megawatts em 100 dias e o projeto ficou finalizado em 60. A bateria armazena energia eólica produzida localmente. Elon Musk é o dono da Tesla, uma empresa que vende não só carros puramente elétricos, mas também o Solar Roof, telhas com painéis fotovoltaicos, e o Powerwall, que armazena a energia produzida pelo Solar Roof. E isto é o que ele tem a dizer sobre energias renováveis.
By definition, we must move to renewable energy. I think people sometimes, how can one argue against that? Because to argue for it is to say that we will eventually run out of energy and die. Or civilization will collapse. So obviously, we must find ways to produce energy in a renewable manner. The question is just how hard we should try, what pace we should go at it. And I think logically we should go as fast as we can because since we know we have to get there eventually, it's better to get to a renewable future, a sustainable future sooner rather than later. Get there before we do the environmental damage, not after. And even if one could say that well, maybe there isn't that much environmental damage, to play the devil's advocate, maybe the environmental damage, maybe it won't be that bad. Why take the chance? Now, a lot of people would say, well, solar, can that really provide the energy that we need? But a lot of people don't perhaps appreciate that solar energy is already the source of the vast majority of Earth's energy. Without solar power, we would be a frozen ice ball at about 3 or 4 degrees above absolute zero. So really all we're talking about for solar electricity is taking the tiny bit of energy that humanity needs for electricity, which I emphasize is super tiny compared to the amount of solar energy that hits the Earth. I think the important thing to bear in mind with batteries is there really is no material shortage. The Earth's crust has essentially an infinite amount of metal as far as humanity is concerned. We have barely scratched the surface of the metal resource availability of the Earth's crust. And this is a very fundamentally different thing from mining coal or oil or because metal is recycled. So once you have enough metal to support a given size of industry, then it just keeps going in a recycling process. I mean, there may be a small amount that exits the recycling process, but it's quite a small amount. So for lithium-ion battery packs, in the case of Tesla, the cathode, which is made of nickel, cobalt, and aluminum, is the most expensive part of the cell. The anode is made of carbon, and then there's a thin steel shell around the cell. So really the only part of that is remotely scarce, and only slightly so, is cobalt. And that's why we moved from a pure cobalt cathode to nickel, cobalt, aluminum cathode, which uses only about a quarter as much cobalt. But there's as much nickel as you could possibly want, certainly as much as aluminum as you'd need, no shortage of steel, and the cobalt it's expensive, but there's certainly plenty available to support all the world's needs. So there really is not some fundamental metals shortage with respect to battery packs. Then as I mentioned, at the end of life, you recycle them. And you can think of a battery pack as basically really high-grade ore. It's much more efficient to recycle a battery pack, which has essentially very high concentrations of nickel, cobalt, and aluminum, than it is to mine rock, which has a very low concentration. So it's at end of life, a lithium-ion battery pack has still about 10 to 20% of its value as a recycling item. So you definitely it pays to recycle.